All right, let's take a look at your horizontal projectile questions. Come on, focus. There we go. Number 1 on page 536. An airplane is dropping supplies to a northern village that are isolated by severe blizzards and cannot be reached by land vehicles. The airplane is flying at an altitude of 785 meters and it's at a constant horizontal velocity of 53.5 meters per second. So it's going this way. Okay, so it has a VIX. It's going to drop the packages, and when it drops the packages, they're going to have the same VIX as the plane because they were inside the plane. So if this is the village here, the pilot has to think about, I need to drop them back here. And so the question is, how far back? So we separate our givens into X and Y. So we have our VIX, it tells us it's 53.5 meters per second. And, sorry, I don't know if that light, if I take that light off, is it better? Not really. And we have our VIY is 0 meters per second. Our AY is 9.81 meters per second squared. Our AX is 0. This guy's down. And our delta dy is 785 meters, and it's down. And the question wants to know how far back, what's the delta dx? And of course, we don't know the time, but whatever it is, it's the same for both. So if you take a look, you don't know, you only have one unknown in the y's, so start there. So start with delta dy is equal to VIY delta t, plus 1/2 AY delta t squared. This goes to 0. Rearrange for t squared. So delta t squared, multiply both sides by 2 delta dy over a y. So 2 times 785 meters. Everything's going down, so we don't have to call either negative. Divided by 9.81 meters per second squared. Remember, that's going to give you t squared, so don't forget to take the square root. So before the square root, you get 160. After the square root, you get 12.65 seconds. So now that you have that time, now you go back to the x direction. And in the x direction, you can use, sorry, my hand is reflecting the light, and then delta dx is equal to VIX delta t plus 1/2 AX delta t squared, but the AX term is 0. So 53.6 meters per second, 12.65 seconds, multiply them together, get a delta dx of 676.8 meters. You are finished, number 1. Number 2, a cougar is crouched in a branch of a tree. So here's my tree branch, here's my cougar. It's a baby cougar. Okay. 3.82 meters above the ground, he sees an unsuspecting rabbit. Who writes these questions? So do my bunny. I have to give the bunny a fighting chance. Okay, so the cougar's going to jump horizontally, and he's going to land on the bunny's back just so that they can play, because he's a little cougar and a big bunny. All right, and so the question says so it's a horizontal projectile, so VIY is 0, and you're looking for VIX. It says the branch, delta dy, is 3.82 meters above the ground. And of course, AY is 9.81 meters per second squared, and that's also down. We know AX is 0. And it says the bunny is 4.12 meters away. Okay, and whatever the time is that we don't know, it's the same for both. So again, you only have one unknown in the y direction, so do the y direction first. So delta dy is equal to VIY delta t, 1/2 ay delta t squared. The vi part is 0. Solving for delta t, multiply by 2, divide by a. So 2 times 3.82 meters divided by 9.81 meters per second squared. Again, we don't have to worry about negatives. Everything's going down. And again, that's t squared. Don't forget to take the square root. Before the square root, it's 0.778797. After the square root, it's 0.8825 seconds. Okay? So this is the time that the little cougar's in the air. Now we go back to delta dx is equal to vix delta t, 1/2 ax delta t squared. It's the ax term that goes to 0, and this time we're looking for vix. So divide the delta dx by the delta t. So 4.12 meters divided by that 0.88, what was it, 25 seconds. And you should get a VIX of 4.6686 meters per second for the little cougar. No small animals can be heard in the making of these questions, so I had to make the cougar tiny. Number 3. A skier leaves a ski jump with a horizontal velocity of, so you have a VIX again. And so in the x direction, our VIX 22.4 meters per second. Our VIY 0. AY 9.81 meters per second squared down. AX 0. And it says if the landing point is 78.5 meters lower than the end of the ski jump, what's the horizontal distance and what's the final velocity? So delta dy is 78, whoops, that dot is not there, it just looks like it is, 78.5 meters, and it's below, lower, and we want to know what is delta dx, and we also want to know the final velocity, so we need vfx and we need vfy. Okay, and of course we don't have the time. So where are we starting? First, let's start with, let's find the time in the y direction like we've been doing. So delta dy is equal to viy delta t, 1/2 ay delta t squared. viy goes to 0 again, so t squared is going to be equal to 2 delta dy over ay. So 2 times 78.5 meters over 9.81 meters per second squared. Again, don't forget to take the square root. You get 16 before the square root, you get 4.0005. For those of you who like to keep all your decimals, let me keep a few. Okay, then in the x direction, delta dx is equal to vix delta t, 1/2 ax delta t squared. This term goes to 0, and we're looking for delta dx. So delta dx is equal to 22.4 meters per second was my vix times the 4 seconds. Delta dx ends up equaling, oh, I think I screwed up, because I did it on my calculator, and I definitely don't get 105 when I do it in my head, I don't think. So 22.4 times 4.0005. 89, that looks better. 89.6112 meters. I think I multiplied it by 5 instead of 4 when I did it in the calculator. All right, and then it wants VF. So remember, our VF is going to be here, and we need our VFX and our VFY. It's really going to be up there, but it's in the middle of the diagram, in the given. So VFX is just going to be VIX because A is 0, so 22.4 meters per second. And I can find my VFY by doing VFY squared equals VIY squared plus 2AY delta dy, and this goes to 0. So VFY squared is equal to 2 times 9.81 meters per second squared times 78.5 meters. Don't forget to take the square root, and you get a